Let's pump in some energy and start our Terminal Group weekend session. And today I'll be sharing some Python basics that might come in handy. Let's see how many you already know. With the first one coming as the F string. Don't get me wrong about it. The F string is something which helps you save a lot of time, save a lot of syntax. So let's dive into the Python terminal. And let's see how would you generally type in variables with a print statement. So for example, you have a name called Sam, you have his age called 10 years, and you want to print his age and say, probably you want to say his age is 10 years. So you would type in something like this, in which you would use the format method on string, and you would pass in positional arguments, and the output would be as expected, the string with the variables. Or you would type in something like this, in which you're passing in keyword arguments, and we'll get the expected output. Where the F string really comes in handy is that you do not need to use the format method, and you can just specify print F. You can just prefix F before the string, starting of the string, and you'll get the same output. The second is the warlus operator. And let's see how we want to use that. So we're in the Python terminal again. And for example, you have a list, and you want to say whenever the list length is greater than 2, then you want to print the length of the list. Okay, simple. So you would type in some code like this, and you would say, okay, length of A is, if it's greater than 2, you capture the length of A in length variable, and then you print the length. Now, the problem with this is that the program actually calculated the length of A over here, and then it calculated length of A again, which I think can be optimized, and that's where the warlus operator comes in handy. So the way you would do this is by printing in this particular colon and equal to. So this is the sign of warlus operator, and obviously you would close this with the brackets. Now what you're saying is that capture the length of A in variable length, and then you use that variable in your print statement. Instead of doing the calculation twice, you're just doing it once, and that's where you're actually checking also in the conditional statement. So this really optimizes the code. Now the output is exactly the same. So the next which we have is finally. Now many of you might know how to use finally, and let me see if I can surprise you with it. One of the functions. So for example, you have a function 1, and you're saying that if you get 5, then you return 5, and in the finally operator return 10. Now most of you might know that finally is executed irrespective of there is an error in the statements which you're trying to capture in try or except. Irrespective of that, the finally would be executed. So what you need to keep in mind over here is, even though you're trying to return 5, you will be surprised to see what exactly is the output. So we'll try to call the function. We're passing in a variable 15, and we're getting the output 10, even though this was executed first, and it should have returned 5. But even if there's a return, the finally gets executed before that. Something interesting. The next up which we have is comprehensions. Now, comprehensions are something which really strip down your code from 4 line to maybe 1 line. And the way this works is that, for example, you have a list and you want to generate odd items, right? You want to generate odd items. So the way you would do is you would probably put in a for statement and then do string, and you would try to store it in a list and do list.append whenever that for item gets captured, right? Now, there's a really sweet way to do this is by saying this is a list comprehension. What you're saying is that execute for I in range 1 to 20, and you need to keep a gap of 2 between them, and whatever the value comes in the variable I, you store it in this and form it as a list. So if you see, the S will be a 1, 3, 5, 7, 9, 11, 13, 15, 17, 19. So it's very easy. Otherwise, this code you would have written in almost 3 to 4 lines. The next up which we have is in. Now most of you might know that in is used at a lot of places to check if the value exists in a list or a string. And the way we're going to use this is that most of you might come across where you're asking for user inputs in your string, and you want to make sure that user enters either yes or no. And this is where in can come in really handy. So for example, you do answer equals to none, and you put in a while loop and saying that if the answer is not in the list, so you're using the in, then you just keep asking them, do you wish to continue or not? So they're bound to put in yes or no. So for example, yes, if I type in yes, it'll exit out. But if I type in A as D, if I type in 1, 2, 3, if I type in anything, if I type in exclamation, it'll not just break out of the loop. You either need to type in yes or no. So you type in yes and it moves out of the loop. So this is where in I found was really handy, where you have to put in a loop and say, you have to enter one of these characters, otherwise you're not coming out of the loop. The next up which we have is zip. Zip is a function which I've seen very less people using it, and it's very handy. And I'll show you one of the use of it. So for example, you wanna do some kind of mapping between 2 to 3 lists. So for example, you have a list called A, and you have 1, 2, 3, 4, 5, 6, and then you have a list called B, and you have a list called C in which you have Roman numbers, right? Now, if I ask you to sort these lists and give me the corresponding 0 index of A and B and C mapped together, and then going forward, you need to do it for all the indexes in the list, then probably you'll put in some complex logic and put in for loop and something like that. Zip really comes in handy. What you do is it gives you an iterable, so you need to put in for loop, and you just pass in iterable. So you pass A, B, and C. And what you say is that print I. So now what you get is you have a tuple which maps 0th index of the first iterable with the second iterable and the third iterable. You can pass in many. And zip takes the shortest string to terminate its operation. So if the A string was just till 3, then you would have just seen till third index, and you would have not seen even though 4, 5, 6 was there in B or C. So you would have not seen 4, 5, 6 even though it was there in other list. So yeah, this function I found really handy. The next up function which we have is star and double star. A lot of people get confused that what exactly we're using star and double star for is the way you would use star and double star is this is basically used in passing arguments in functions and clauses. And so for example, we have this function, and now what it's saying is that you can pass in any number of positional arguments. So it doesn't care. It doesn't care how many arguments. So generally we would specify that I need so and so arguments. So it says, no, you can pass in any number of positional arguments. And this says that you can pass in any number of keyword arguments. I want to pass in 1, 2, 3, 4, 5, and you can keep on going on. And then I want to pass in the keyword arguments 6 equals to 6, 7 equals to 7, 8 equals to 8. So there is no limit. And the way you would handle this is in the program, the way this would come in is it will come in as a tuple and a dictionary. So now you can just, if you know what's going to come in or what, you can just use that in your program. Now, next up we have is no return. Now, what is no return? It's always a good practice that the function either returns none or it returns only one type of data. Like it only returns integer, it only returns a string, or it only returns a dictionary, or it only returns list. It should not be that in some condition it's returning list, in some condition it's returning dictionary. So either it should return one kind of data type or none. You have a function which says if the number is greater than 100, then I will return 100. But if you see what happens if there is else condition. So by default, if a function does not have a return statement getting encountered, then it will return none. And this is generally practice which you can follow. So if I try to call this function print, I should get 100, right? But if my condition goes false, I should get none, which is, I think, the ideal way to have something returned if there's a false condition. Next up, which we have is append versus index. For example, if you have two lists, right? You have A and then you have B with the numbers. What you would do is if you do A dot append B, it'll put in the complete list 6, 7, 8, 9, 10, and it will not increase the index till 10. What I mean is that if you see, we have 1, 2, 3, 4, 5. So this is index 0, 1, 2, 3, 4, and in the fifth index you have the complete list. It did not extend the list. So you have a complete extend method for the list, and what you can do is you can just say, I'm just putting it back to the way it was, and if I do extend B, then what you get is the expected output. I mean, in case if you want this. Next up, which we have is lists are mutable. This is something which is very interesting, I've found. Sometimes people wonder and scratch their head that why the list value has changed, even though it was inside a function. So to demonstrate this, I have the following code for you. So for example, if you have a string and if you have a list, right, and you have a function which just says, this statement says I want to increase the number by 1, and this says that I want to increase the list and have one more number added to it, which is 2. Now when we call the function, then it gets interesting. When we call the function, we get the values from the function as 2 and 1, 2, which is right because we are printing inside the function. When I check the value of s again, it's because I'm accessing the s which is outside the function, it's reverted to 1. And when I access the L value, it should be 1, but it would not be, because L are actually in place replacement they do. So now you have L changed, and the function has changed the value of L outside the enclosure. So that's something which you should keep in mind, and you should not get confused that why is L value changing even though it's even though you're accessing outside the enclosure. I think these tips were helpful, and yeah, it was fun. Take care.